So we're continuing on with our notes here. Each video is about 10 minutes long, and just remember, pause it if you need to so you can get it all down. So looking at our picture over here, this just shows us the air pressure with elevation. So hopefully you can see that here the pressure is increasing as it goes to the right, and so when you're at really high altitudes, there's not much air up there, and so there's not many particles moving around, bouncing around, and so the pressure is small. But because gravity pulls most of our gases to the Earth's surface, as you move down in altitude, the air gets thicker and thicker, and because it's thicker, now there's more particles to bounce around, causing more pressure, right? So if you were to think of it, there's a lot of particles here, there's a high density, and so all those particles move around, hitting things, causing pressure, but way up high in the atmosphere, the air is thin, and so there's just a couple particles, right, or much fewer particles to move around and cause pressure. It can also change with weather, and this is why you hear in the weather they talk about the air pressure is rising or the air pressure is lowering, and they'll say the barometer is rising, the barometer is lowering, and it basically kind of tells us about weather changes. Because if you think about air, right, air is full of O2, a bunch of N2, and some CO2, right? And all of those particles are causing the air pressure. And remember, another way of measuring air pressure is measuring the weight of all of those particles. So if water vapor has a molar mass of 18 grams per mole, well, if you look at air, air is made up of 78% nitrogen. Well, nitrogen is only 14 grams per mole. And we're at 21% oxygen. Sorry, nitrogen's 20. Yeah, that's what I said, 28 grams per mole. Oxygen is 32 grams per mole. Well, water vapor is much lighter than nitrogen and oxygen. So if there's water vapor in the air, now all of a sudden there isn't quite as much N2 and isn't quite as much oxygen because there's water molecules mixed in there. And because water is lighter than those other oxygen and nitrogen atoms, that means that there's going to be less pressure. So when the barometer's falling or when the pressure is falling, that means that there's more moisture in the air, and with moisture comes weather change, right? We get rain with that. So rain can be predicted with a lowering atmospheric pressure, right? It says that it's going to be more humid and that could cause some rain or the formation of clouds. So how they do this is they use barometers to measure the air pressure. So what happens is, right, remember the weight of the air causes air pressure. And so if the weight of the air is pushing down on here, right, what happens is it forces mercury, and mercury is very stable. It's not compressible. It stays a liquid at multiple temperatures. So what happens is this air pressure pushes mercury up, and that this column of mercury right here has a weight that's equal to kind of the pressure that's being pushed down here. So the weight of this column of mercury causes a pressure that's equal to the atmospheric pressure. And so you can see that it's 760 millimeters of mercury. So 1 ATM, 1 atmospheric pressure equals 760 millimeters of mercury, because 1 atm of atmospheric pressure will make a column that is 760 millimeters tall of mercury. So that's where that conversion comes from, right? The air pressure pushes the mercury up that tube. So a barometer consists of a tube with mercury that's placed upside down in an open dish of mercury, right? The top of the tube is a vacuum, so there's no air pressure in that vacuum. The bottom of the tube is open to the atmosphere, and mercury doesn't evaporate either, so you don't have to worry about your mercury disappearing over time. So as I explained, right, what's going to happen is that atmosphere is going to push the mercury up the tube, and then they put a scale on there, and we can measure it, right? And we can look to see, okay, well, if the air pressure increases, then that means the weight of this column has to equal the pressure, the increased pressure, and so the mercury rises up the tube. It fills up more of the tube. So we know the pressure is increasing, right? Because on our barometer, there's more millimeters of mercury. There's a greater height there of mercury. And when the pressure is falling, well, then we need a smaller tube filled with mercury, and so the pressure is decreasing. Remember, pause this to fill out your notes. Okay, and remember, right, like I said before, 1 atm is 760 millimeters of mercury, and that's because it's 760 millimeters high is where that number comes from. That'll get you to, I think, page 3 of your notes. So now we're going to go on to manometers, but I think I'll stop the video there. It's not quite 10 minutes, but then we'll talk about manometers.